Week 1 notes, factoring a trinomial. When we're factoring a trinomial, it's a little bit different than just factoring a GCF out of a polynomial. And the reason is, if we look at these three polynomials, they have absolutely nothing, or excuse me, the three terms in this polynomial, they have absolutely nothing in common. If we take a look at x squared, 8x, and 12, they don't all have an x, and they don't all have a common factor, a common number that I can divide out of each. But they can actually be factored into two binomials. And if you remember back when you were working on multiplying two binomials, they always ended up looking like a trinomial, three terms, almost always, unless we had a special product. So our goal here is to get the two binomials that multiply to make these three terms. So let's take a look at a packet, a worksheet that's in the packet I gave you the first week of class. Looks like this. And we're going to go through one of the examples, one or two of the examples on this packet. So I hope you can find it. If not, just draw these baseball diamonds and work the problems with me as you go. We're going to go to the example in the middle of the page, right here. We're going to attempt to factor x squared plus 12x plus 35. Now it's some binomial, two binomials multiplied by each other that produce this. And here's how we think about it. When we're multiplying these binomials out, remember how, I'm just going to grab a piece of scratch paper here first. Remember how, let's say I have this binomial. The first two terms that we multiply give us x squared usually, or n squared, or a squared, or something squared. And then the next term, the outers, give us something like this, 3x. Now the next one usually was a like term. In this case I'd get 2x. And usually these two combined, we could add them together. The last term came from multiplying the two plain numbers. So when we finish this one up, we get x squared plus, we can add these two together, 5x plus 6. So the last term in the polynomial came from multiplying these two guys. The middle term in the polynomial came from adding this one and putting an x on it. So if we look at this little baseball diamond thing that I have going on the worksheet we're going to go back to in just a moment, if we make ourselves a baseball diamond and we think about times here and addition here, and we look for the last number in our polynomial, the constant, the 6, and we put it at the top of our baseball diamond, and the 5 that results as combining the two middle terms, and we put that here, and we think, okay, this was achieved by multiplying two numbers, this was achieved by adding two numbers. What two numbers, what two factors of 6 also add up to 5? So we're pretending we don't know this is where this polynomial came from. We're just trying to guess what two numbers add up to 6, multiply to make 6 and add up to 5. Eventually you might come up with either 6 times 1, nope, 6 plus 1 is not 5, it's 7. How about 3 and 2? 3 times 2 is 6, 3 plus 2 is 5, and then we're able to write our binomial out like this. Put an x in the first spot in each parentheses, and then put plus 3 in one of them, and plus 2 in the other, and we end up with the same pair of binomials we started with. I've got them in the other order, but order doesn't matter when you multiply. It will still give me this polynomial. So hopefully you followed all that. We're going to start another one from scratch. So I've got x squared plus 12x plus 35. And I want to think about the two binomials that multiplied to make this. Now I know x goes here and x goes here because that's what produces the x squared. What I'm trying to figure out is plus what and plus what. So I'm going to get my plus signs ready. So I set up my baseball diamond, and I've got the answers in it already. But think about the top number as what multiplies to make 35. What two numbers? And what two numbers add up to 12? And I came up with 7 and 5. 7 times 5 is 35. 7 plus 5 is 12. So my answer is then x plus 5 for the 5 on this corner of the diamond, and x plus 7 for the 7 here. Now if you multiply this back out, let's do it mentally. X times x is x squared. This will give me 5x, and these two will give me 7x. 5x and 7x make the 12x in the middle. And then when I multiply the two last numbers, the constants, 5 times 7 will make 35. So the factored form of x squared plus 12x plus 35 is x plus 5 times x plus 7. Let's try one more of these, and in class we can do a bunch together as practice. But let's try how about number 15? Alright, so this baseball diamond is going to be related to some polynomial down below. It's actually the answer to factoring one of these down below. So in setting it up, we think about what two numbers multiply to make 45 but add up to negative 14. Multiply to make 45, add up to negative 14. Start thinking about factor pairs of 45. Let's see, we've got 45 times 1, 2 doesn't go into 45, 3 times 15, 4 doesn't go into 45, 5 times 9, and I think those are it for our factor pairs. So I'm going to grab a pair of those that adds up to negative 14. Well, these two add up to positive 14, so how can I get them to add up to negative 14? Well, let's think about it this way. How about negative 9 times negative 5? They add up to negative 14, and a negative 9 and a negative 5 also multiply to make a positive 45. Now, you have to play around with these a little bit. It just doesn't always come at the blink of an eye. You have to play with those factor pairs and work out the negatives and positives until you get the right combination. And if I go down here now, here's the polynomial that's related to this baseball diamond. It's got the 45 as the constant. It's got the minus 14x in the middle. So how do I interpret this? What's my binomial? Well, I know x goes in the first spot to give us x squared here. And then I write minus 9 minus 5. So the binomial pair that multiply to make this polynomial are x minus 9 times x minus 5. Tune in for part 2, and we'll practice factoring some more.